Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to find the slope of tangent of this interesting graph at the point x is equal to e. That is, to find the derivative of the function. I'm going to show you how to change the form of this function, how to differentiate it, to compute the slope, and we shall look at a really special point of the graph as a bonus. First thing first, the infinite radicals are too complicated. We cannot differentiate it right away. To simplify it, let's take power x on both sides. Then the left-hand side is just y to the power of x. For the right-hand side, the first radical of x and the power x are cancelled. Therefore, we have x times the infinite radicals. Now, can you recognize something? Right. If you ignore the first x, then the rest of the term is exactly the same as the original function y. Therefore, the right-hand side is a much simpler term, x times y. Now, we can divide both sides by y, then it becomes y to the power of x minus 1 is equal to x. To get only y, but not y to a certain power on the left-hand side, we take the index 1 over x minus 1 on both sides. Therefore, the equation of the graph becomes y is equal to x to the power of 1 over x minus 1. This form is much better to handle. Our next step is to differentiate it, but we can't use the power rule directly because it's for constant index n. For the graph, the power is 1 over x minus 1, which is a variable instead of constant. So what should we do? Let's take log on both sides of the equation. Then we can use the property of logarithm to bring the index down. So the equation is log y is equal to log x over x minus 1. Now, differentiate both sides with respect to x. On the left-hand side, the variable here is y, but not x. So we have to apply the chain rule. It's changed to the log y dy times dy dx. Here, differentiate log y is 1 over y. This method is called the logarithmic differentiation. It is used in another question of trigonometry. You can find the link of that video in the description below. For the right-hand side, we apply the quotient rule. It's shown in the blue rectangle. The two functions log x and x minus 1 are easy to differentiate. Therefore, it's equal to x minus 1 times 1 over x minus log x times 1 all over x minus 1 whole square. Let's simplify this expression. Multiply both numerator and denominator by x. The right-hand side is x minus 1 minus x times log x all over x times x minus 1 whole square. Multiply y on both sides of the equation, then we get dy dx in terms of x and y. We are ready to find the slope of tangent. From the equation of the graph, when x is equal to e, y is equal to e to the power of 1 over e minus 1. Putting these two values into the equation, then dy dx is equal to this expression. Because log e is equal to 1, therefore these two terms cancel out. We get the slope of tangent, which is negative e to the power of 1 over e minus 1 all over e times bracket e minus 1 whole square. Everything looks good. So what's the special point of the graph? When x is equal to 1, can you find the value of y? If you use the equation of the graph and put x equals to 1 inside, you get 1 to the power of 1 over 0. We know that 1 over 0 tends to infinity. So what do we mean by 1 to the power of infinity? On the other hand, if we use the original equation of the graph, then we have infinite radicals of 1. You might think that is equal to 1, but from the graph, the value of y is larger than 1. It's actually 2 point dot dot dot. It's so weird. What's the mystery underneath? If you want to know more about this interesting graph, let me know in the comment section. I shall make another video on that. Please also check out the links of the videos of calculus and playlists on the screen and the descriptions below. See you in next video.